So how do we know that there are these different type of waves? How do we know? Because we can actually distinguish waves according to their period. Okay? For example, we can identify tides, okay? Because they have specific periods. So if we, for example, measure sea level elevations over time, okay, and we produce a plot that's shown here, which allocates the relative energy. It's essentially the amplitude of the wave squared, okay, as a function of the period of the wave. So there are mathematical techniques by which you can produce a so-called spectrum, where wave spectrum, you actually get a distribution like this, shown here in this graph. Okay, so, and from this we can identify the peaks of waves, and they have different periods. For example, you have wind waves created by the wind. Here it's something like 5 seconds. So you see here the x-axis is actually not a linear. You have 1 second, and then you have 10 seconds, you have 100 seconds, you have 1,000 seconds, 10,000 seconds, and so on. You can see the translation into minutes, hours, days, and weeks, and so on. Okay. So then swell you can identify by a peak which has a longer period. Okay, we're talking about 15 seconds, 12 seconds, something like that as well. And then you can identify the tides. The tides have specific periods, and they have a high energy. You have you get a strong signal. You also get inertial oscillations, and then you even get waves which have a period of 100 days and longer. So all these waves, you can distinguish them, but they also occur at the same time in the oceans. You have the same time. You have wind waves at the same time as you have tides, and as you can have inertial oscillations. So what we can do, though, because you can distinguish them, you can also explore them individually, and that's what we will be doing. Okay, they don't interfere with each other. Okay, so tides don't influence much the wind-created waves in the earth. All right.